Hey, good morning, guys. This is Aynesworth again, and yet one of his another videos here at AP Pre-Calc here in year 2023 at Great Oak High School. So here we go. We are done with Unit 1, and we're going to start getting ready for an exam. Okay, so that's why it's called Unit 1 Review. So get out your pencil, red pen, get out your TID4, whatever you need here. You might be doing some graphing, who knows? All right, so use TID4 when applicable here, and let's get started. And of course, you have your notes. You can access your notes at any time. So let me get you started here. First, by reading the directiones. All right, begin in cell 1. All right, so this is number 1 here, obviously. Okay, and don't be misled on these answers here. It doesn't imply that the answer to number 1 is 76. So let's read the directions to figure this out. Begin in cell number 1, which happens to be here. All right. Show the work necessary to arrive at your answer. Search for your answer in one of the other cells and mark it number 2, cell number 2, and then work out the new problem. Proceed in this manner until you complete the circuit, which means you arrive back at the first box. Like a circuit, you start at 1, and then you go through all the other problems, and then you have to back at cell number 1, which means the last problem has to have the answer of 76. As noted in the upper right hand corner here. So if that didn't make any sense, let's go through a few. So the first one here says find the average rate of change. Okay, that's AROC. So let's define that. Okay, so here we go at the top. So the AROC. So on an interval, okay, so let's say from A to B, right here, the average rate of change is equal to f evaluated at B, which is your right endpoint, okay, minus f of A, divided by B minus A, which is your length of the interval from B to A, or from A to B. Okay, and then remember, this is the slope of the secant line. So remember, this is just a fancy way of saying slope of the secant line going through those 2 points, A comma FA and B comma F of B. So the slope of the secant line, or what's called the average rate of change. Okay, so if we're going to get the average rate of change on the interval from -2 to 0, then we know what our interval is, we know what A and B are, and we need to evaluate G, which is just a linear function at these points. So the first thing you need to do is find G of -2, because A is -2. You substitute that in your function. All right, so -5, excuse me, plus 3 times -2 minus 1. You just substitute it in, right? And then this should be easy for you guys. And then let me see. So -2 minus 1 is -3 times 3 is -9. And then -9 plus -5, -14. So this is -14. All right. And then you do that for G of 0. So you evaluate the function at A and B. So 0. So 0 minus 1. I'll just work it out here. So -5 plus 3 times 0 minus 1. So 3 times -1 is -3. Plus a -5 is -8. So now I have my function values, and now I go for it. Okay, so the average rate of change is equal to, again, f of, okay, B first, so f of 0, oh, excuse me, G, sorry. So let me start off with G of 0 minus G of -2, all divided by 0 minus a -2. So now I have my function values. I know what they are, and G of 0 is -8. So -8 minus G of -2, which I just calculated, is -14, all divided by 2. 0 minus a -2 is 2. And then you just work this out. You get you get -8 plus 14. There's a double negative. Okay, so you do the arithmetic. -8 plus 14 is 6, and 6 divided by 2 is 3. So 6 divided by 2 is 3. So I should probably stay in the same color. Okay, so anyway, 6 divided by 2 is 3. Now what I do is I search for the answer for 3, and that becomes problem number 2. And so notice, let me highlight the answers here. So they're all up through here, so you keep on searching. And then notice here that 3 I found it, it's right here. So there's my average rate of change. It's the same as this, so this becomes a number 2. Problem number 2. So it says, show at the top in the directions, show your work necessary to arrive at your answer. I did that. Search for your answer in one of the other cells and mark that number 2. So we start off with number 1, came up with an average rate of change of 3. which is down here, this fourth problem, and that becomes number 2. Then I solve number 2 and I find its answer. So I'll do another one. Okay, so now we're solving this one here. So we're not going in order, we're going according to the directions. This is a circuit, and so if we do this right, we should end up back at number 1. So our last problem that we do should have an answer of 76, so we end up back at 1. Okay, so quadratic function is a quadratic, second degree. So that's the first thing we need to know, second degree. Okay, select the values of f as shown in the table, or selected values are given in the table. And again, look at this, find the average rate of change. All right, so on the interval from 6 to 8. So A is 6 and B is 8. So there's your interval. So let's highlight the interval that we need to take a look at. Okay, so interpreting here, A is 6, B is 8. F of 6 says 21, and then F of 8 it says is 45. So if I was going to figure out the rate of change or the average rate of change, it's F of 8, always start on the right side of the interval, minus F of, oops, not A, 6 in this case, because again, the interval is from 6 to 8. All right, all divided by 8 minus 6. Now here, unlike the first problem here, first problem you have to actually calculate g of -2 and g of 0 because they give you a function. Here we don't have to calculate because they give it to you in the table. All right, we know f of 6 is 21, f of 8 is 45. They're function values, they're y values. So when I say function values, I'm talking about the y values. F of 8 is 45, so f 45 minus f of 6, which is 21, all divided by 2, because 8 minus 6 is 2. And then you subtract, you get 24 divided by 2, and the answer is 2. So in this case, 12. Sorry, 24 divided by 2 is typically 12, especially on Wednesday, right guys? Right. Okay, so the average rate of change on this problem is 12, and now I go search for the answer for 12. Now if you look at the page 1 here, and the answers are in yellow here, none of them, the first one's 76, and then 200, 5, and then 3, and then 3.5, so they're not here. So you got to keep on searching for it, so I'm going to keep on going here. And you got to look at the answers, and you got to find the average rate of change of, or the answer is, you got to find an answer of 12. So that's -4,000, -1, 3 halves, 2, -3. Ah, here it is, answer of 12. So right there, that becomes problem number 3. So you label it 3. Okay, then you work it out. So you just follow, they call this a circuit because if you do it correctly, you end up back at number 1 to complete the circuit. So you gotta, it's kind of like going in a circle. You gotta follow the circuit and end up back where you started. So you gotta end up with back number 1 somehow. So in this one here, let's read it together. Let's do a few more. It says the function is a quadratic. Ooh, we learned something about quadratics here. And it says find f of 1. Now this is going to be challenging. We are not giving a function. 1's not even in the table. So how are we going to do this? How are we going to do this? Find f of 1. Let's see. So we need the function actually to do this. So how are we going to do this? Let's see here. What method should we choose? It's quadratic. Okay, so we're going to continue here and see how to approach it. So a quadratic in general looks like y is equal to ax squared plus b x plus c. That's from, believe it or not, algebra 1. The question is, how do you find the function so you can evaluate it at 1? Because the x value is 1, and guess what is not in the table? And you can't just look at the rate of change, because the rate of change is not constant for a quadratic. It's the second difference that's constant for a quadratic. But the question is, like, how do you evaluate the function at 1 when we don't have the function itself? So I'm going to go to the side here and go over here and work on this one here. So I'm going to just write down my general function. And I don't know if you guys have ever done this before in Algebra 2, but here we go. Okay, I'm going to use points in the table. So my first point I'm going to pick is this one here. So I'm going to substitute 0 in, and my y value should be -3. So y is -3 when x is 0. So a times 0 squared plus b times 0 plus c. Well, use your common sense here. So these are 0, that's 0, and so a -3 is equal to c. So now I know what c is. It's -3. So the only thing I need to find is a and b. So what we do is we use a couple more points. So now I'm going to use the second point in the table, 2 comma -3. So y is -3 here when x is 2. So I'm going to substitute 2 in. So a times 2 squared, all right, plus b times 2, because I'm substituting 2 in. All right, now I already know c. C is -3. That goes here. Okay, so -3. So what do we? Let's simplify this. So -3 is equal to 2 squared is 4, so 4a plus b times 2, which is 2b, minus 3. Let's simplify a little bit further here. Let's add 3. So 0 is equal to 4a plus 2b. Okay, so I have two unknowns, and you learned in Algebra 1 and 2 that with two unknowns, you have to form two equations. Okay, so now I'm going to have to use my third point. So now I'm going to use 4 comma 5. And so if I use this point, x is 4, y is 5. So here we go. So I'm going to substitute this in the function. All right, so y is 5. So 5 is equal to a times 4 squared, because x is 4, plus b times 4, and then minus 3. C is -3 every single time. We already found that out initially. So let's simplify this. 5 is equal to 16a plus 4b minus 3. I'm going to add 3 to both sides just to make it look like the other equation. And I get 8 equals 16a plus 4b. So now I have two equations, two unknowns. And then you guys were taught how to solve these. Okay, so what I'm going to do, I need to multiply the first equation by some number so I can cancel out either one of the variables. So if I multiply this first equation by -2, I can cancel out the b's, which I'm going to do. So I'm going to multiply this one by -2. So right here, times by -2, I get 0 here, and I get -8a minus 4b. I'm going to bring that over here and line it up and solve the system. This is just Algebra 1 and 2 stuff. So yeah, in pre-calc you have to use a lot of prior skills like solving systems of equations. So here we get 8 is equal to 8a plus 0. So divide by 8, so a is 1. Alright, so now I know a is 1. So now I just substitute a and 1 for a for one of these equations. So I'm going to take this one down here. 0 is, we already know it's equal to 4a plus 2b. But if I substitute 1 in, I get 0 equals 4 times 1 plus 2b. That gives me 0 equals 4 plus 2b. Solve. I get -4 equals 2b. So that tells me that b is -2. So having done all this, now I know my equation. So y is equal to a, which we know is 1, so x squared. B is -2, so minus 2x. And c we already know is 3. So there's my function. Alright, so I'm going to bring it up here. Y is equal to x squared minus 2x minus 3. I'm going to go back here. I'm going to substitute the value in, and we are done. So f of 1 means you take 1 squared minus 2 times 1 minus 3, and you get 1 minus 2 minus 3. So f of 1 is, well, 1 minus 2 is -1, minus 3 is -4. So I have found the function value. So there's my answer of -4. So now I look for -4 in the answer set. So it's none of these. Oh, there it is right there. So remember, you look in your answer set, and here it is. So now, let me see, we just did number 3, so now this becomes number 4. And now I work on this one because, again, I came up with this answer, and there it is, so this becomes number 4. So we solve number 3, we go to number 4, and then we figure it out. Okay, so I'm going to do one more here just to continue here. If you want to pause the video, now would be a good time. Right? See if you can do this one on your own and then play the video when you're ready to actually check your work here. So pause the video. Okay, I'm going to assume that you already solved it. So here we go. We're going to decide whether the following table represents a linear or quadratic function. Linear means the first difference is constant. I talked about this in class many times. Quadratic, that means the second difference is constant. So I'm writing down what we know. All right, so now let's work out the changes. So from -2 to 0 is +2. So 0 to 4 is +4. 4 to 6 is +2. And then we have a +1 and then a +1. And over here, what do we have? So here we have a change of 3. -8 + 3 is -5. Here is a change of 6, and then a change of 3, and then we don't know what's going on here. So now notice that neither rate of change of x. So at the top, this is called delta x here. That's not constant. Delta y, the change in y, guess what? They're not constant either. So we need to calculate an average rate of change. So the average rate of change is equal to delta y divided by delta x for each one of these. So let's take a look at our first interval right here. Okay, so in that interval right there, what's the average rate of change? Well, delta y is 3, and then delta x is 2, so the slope is 3/2 right there. But it has to be consistent for it to be linear. It has to be constant. So my second rate of change, so let's dig a little deeper here. The second rate of change, using my second interval from 0 to 4, okay, that should be equal to 6 divided by 4. I'm looking at the second interval now. I'm talking about this one. Okay, so that's change of 6 divided by a change in 4. So 6 divided by 4, and guess what? That's 3/2 too, and it's constant. And since the average rate of change is constant, guess what? It is linear. So this is constant average rate of change. That implies that you have a linear function. So there's no guessing here. There's analyzing, as I say in class, okay? There's no guessing, there's analyzing. All right, we don't assume, we analyze. All right, now it's linear. So we answer the question, decide whether the table represents a linear or quadratic. Okay, it's linear because we have a constant average rate of change. Now you got to figure it out. So what would the next one be? All right. So you got to calculate A. So let's calculate A. So we got to find A. We got to find A and B. So find A. So the average rate of change from 4 to A. So let me see. So from 6 to 7 is a +1. How should we do this? Well, you know what? Let's do it this way. Let's just take a look at B minus A. So the average rate of change from A to B is B minus A. So B minus A divided by 8 minus 7. Okay, that means that, and this average rate of change is constant, so it's equal to 3/2. Okay. So okay, so we use, this is the average rate of change here using your last interval, and that interval, this interval here. So B minus A divided by 8 minus 7, that has to be equal to 3/2 because it's constant. We have a linear function. Well, that gives me B minus A divided by 1 equal to 3/2. So in other words, B minus A is equal to 3/2. So how does that help us? How does that help us? what am I saying? So, just lost my train of thought. So, come on, Aynesworth, I just lost my thought. So the average rate of change is constant. I got b minus a is 3/2. It'd be kind of nice to know. So a. Oh, okay. So what do you add to 4 to get to a? That's what we need to do. So a. Let's talk about a. So a is equal to the previous one, 4 plus something. Okay, and guess what? So it's equal to the rate of change, the average rate of change there. So that's plus 3/2 times a change of 1. So from 6 to 7 is a change of 1. So the change from 4 to a should be 3/2 divided by 1, or just simply 3/2 times 1. So 4 plus the rate of change times 1. All right, and that's 1.5 plus 4, or 5.5. Okay, so that would be a. Okay, so a is 5.5. What would b be? So find b minus a. Oh, what am I doing? I don't even need to find a. I just have to find b minus a. So this was actually not even needed. It says I got to read the directions here. Sorry, guys. Find b minus a, and guess what? Boom, there we go. You don't have to know what a and b are individually. You just have to find b minus a. So we know our answer, which is 3/2. Okay, then we're done. Now we go search for that answer. So I'm going to go backwards here. I'm going to try to find 3/2. And, oh, there we go. Now we were just working on number 4. Okay, so I just found 3/2. It's right here, and so this is number 5. And then you solve this problem and get an answer, and then search for the answer. And that's how the game is played. And then if you do it correctly, and if you keep on going, your last question that you solve should be 76, and then it gets you back to number 1, and you complete the circuit. Okay, remember, you do not need a calculator to complete this, but it might help you out here and there. Use it when necessary. But when I did it, I didn't need a calculator. All right, this will get you started. Now you continue, and if I post another video completing this thing, I will upload it to Canvas. We'll see in the time that I have. This is Aynesworth here. I'm going to sign off. I'll see you in class.